Solve the input output model. The question is given the coefficient matrix is A is equal to 0.4, 0.2, 0.1 and 0.3. Obtain the levels of output for x1 and x2 to have the final demand for f1 is equal to 20 and f2 is equal to 15. If you want me to explain the input output model in detail, then please leave your comment in the comment sections. Right now I will be only solving this question. Now the basic what we call Leontief input output model is given by, that is, the total output x is equal to a times x plus d. Okay, now what is meant by these? X denotes the gross output vector, so it shows us gross output vector, and here this A shows us the coefficient matrix, or we call it input coefficient matrix, and D denotes our final demand vector, Specifically, if I write it here, so this A is being given us what we call input coefficient matrix. It is 0.4, 0.2, 0.1 and 0.3. okay, now D is being given us. D is equal to, which is our f1 final demand, f2 which is in fact equal to 20 and 15, and X shows us gross output vector, so which X is equal to x1 and x2. We need to find out the levels of output, that is x1 and x2, for this Leontief input output model. Okay, now if I solve this equation, so we can rewrite it like this. So we have x minus ax is equal to d, or we can take x common and we are left with I minus a, which is equal to d, or x will be equal to x will be equal to d divided by I, or let me rewrite it like this. Our x will be equal to I minus a inverse d. Okay, now this I shows us, or I is our identity matrix, and let me write it here. I is the identity matrix. Okay, so if you want me to solve the or explain the input output model in detail, I will be explaining that very thing also, but in next video if you want me to solve. Now we need to find out I minus a inverse. We call this the Leontief matrix. So let me write it here. So this I minus a is our Leontief matrix, which is equal to I is our identity matrix, and to this we subtract a. A is our input coefficient matrix, which is 0.4, 0.1, 0.2 and 0.3. okay, so if I make some space here, so we can write it like this. When we subtract 1 minus 0.4, it is 1 minus 0.4, it is 0.6. 0 minus 2, it is negative 2, negative 0.2, and 0 minus 0.1, it is negative 0.1, and 1 minus 0.3, it is 0.7. This is our I minus a, what we call Leontief matrix. Okay, now we need to find out the inverse of this Leontief matrix. Now to find out the inverse of the Leontief matrix, what we need to do, we need to find out the determinant of I minus A. So I minus A, its determinant is, how do we find out the determinant? We multiply these two elements first, so 0.6 into 0.7. First we multiply these two, so it is 0.42. Then we subtract and multiply these two. Here minus into minus is plus. 0.2 into 0.1 is 0.02. That gives us, so multiplying these two, then subtract and multiply these two. If you are getting confused, let me rewrite it again. So how do we do it? So we write 0.6 and multiply it with 0.7. Then we subtract and multiply these two. Here since we have negative 0.2 and we multiply it negative 0.1. Okay. Or I minus A will be equal to, so it is 0.42, 0.42, and minus into minus is plus, so we have negative 0.2 into 0.1 is 0.02, which gives us 0.4 is the determinant of Leontief matrix. Next, we need to find out the inverse of this matrix, that is, we need to find out I minus A inverse. And inverse of a matrix, we know it is equal to 1 divided by the determinant of I minus A, which is our Leontief matrix, times the adjoint of this matrix, Leontief matrix. Okay, this is our I minus A matrix. Now first we need to find out adjoint. How do we find the adjoint of the 2 by 2 matrix? Simply what we do, we swap the principal diagonal elements. So these two are called, if we have 1 0 0 2, let us suppose these two are called the principal diagonal elements. We swap them, okay, with each other. So 0.7 will go top left corner, we have 0.7, and this will go to the bottom right corner, so we have 0.6 here. So to find out the adjoint of a 2 by 2 matrix, what we do, we swap the principal diagonal elements and change the signs of the non-principal diagonal elements. So it is negative 0.1, it becomes positive 0.1. Here it is negative 0.2, it becomes positive 0.2. This is simply how to find out the adjoint in a shortcut manner. As I have told you, if you want me to solve it or explain it in detail, I will be explaining in full detail if you want me to do so. So this is the adjoint. Then I minus A inverse is equal to 1 divided by determinant, we got 0.4, and adjoint is this matrix which we calculated 0.7, 0.2, 0.1 and 0.6. Now if I divide 0.4 to each of these elements, we will get I minus A is 1.75, 0.5, I had done the calculation, 0.25 and 1.5. This is our I minus A inverse. Now since we need to find out the x here, and we know that x is equal to x1 x2, it is our gross output vector, it will be equal to I minus A inverse, which is this matrix. I minus A inverse is this matrix, that is 1.75, 0.5, 0.25 and 1.5. To this we multiply the final demand vector, which is F1 and F2, and which is 20 and 15, 20 and 15. Now we need to multiply them, this matrix with this. And how do we do the multiplication? We multiply row with the columns. So we multiply this row with this column and write it here. So we have 1.75 times 20, this plus then 0.25 into 15, 0.25 times 15. Likewise this row and this column, then we write here and multiply this row with this column. So we have 0.5 times 20 plus then we have 1.5 times 15. This is our matrix. Now if I do this multiplication, so the final answer will be, so we will get 38.75 and 32.5. that is our gross output vector will be, that is x is equal to x1 and x2, which is equal to 38.75 and 32.5, which implies our x1 will be equal to 38.75 and x2 will be equal to 32.5. I hope I make myself clear. Let me repeat. If you want me to explain the input output model in detail, then please like this video and give your valuable feedback.